is on linear functions in slope-intercept form. We're going to be finding slope. Slope formula is vertical change divided by the horizontal change, or rise over run, which is equal to y sub 2 minus y sub 1, all of that divided by x sub 2 minus x sub 1, where x sub 2 minus x sub 1 is not allowed to equal 0. If your denominator is equal to 0, this turns into an undefined slope. Another way of seeing this is delta y over delta x. Delta is a Greek letter that represents change. So this is the change in y, all of that over the change in x. Now some people will say it must be y sub 2 minus y sub 1. As long as you are consistent in saying that if your y sub 2 is first in the numerator and your x sub 2 first is in the denominator, that's fine. But if you're consistent saying that y sub 1 is first, then your x sub 1 is first in the denominator. So we're going to do some examples. What is the slope of the line that passes through the given points? So we're going to use the formula change in y over change in x, knowing that you have two coordinates of x and y, and x and y. So our slope, we use the letter m to represent slope from our slope-intercept form. Again, that was y equals mx plus b. We want to find the slope. Slope is the coefficient of your variable x. We want to do change in y over change in x. So the first y value that I'm going to use is the 7. So I'm going to use 7 minus, then the second y value is going to be 5. This is going to be divided by, since I used the 7 for the first y value, I must use my negative 4 for the first x value. So I have negative 4 minus, and then I look for my second x value, which is negative 3. Now you must be careful in stating that you do have a minus, and then you do have the negative 3. When we simplify this out, we have 7 minus 5, which is equal to a positive 2. That's divided by a negative 4 minus a negative 3. A negative 4 minus a negative 3 turns into a negative 4 plus 3. So a negative 4 plus 3 turns into a negative 1, because that's really 3 minus 4. Now we want to simplify this and say that a positive 2 divided by a negative 1 is equal to a negative 2. Our slope is negative 2. We could also notice that this would be a negative 2 divided by 1, so we can see our change in y over our change in x. That means that we will change our y values by decreasing by 2 as the x's increase by 1. For question B, we're going to do the same thing. We're going to have our slope equals our x and our y. So we're going to take our first y value. It does not matter which, as long as you're consistent. So I'll take the 8, since that is my first y value that I see. 8 minus, and then I'll take my next y value, which is a negative 4. Again, we have to be careful to say that it's minus, and then we do the entire y value. We're going to divide this by, since I used 8 for my first y, I need to use my negative 3 for my first x, because these coordinates, these numbers, go together as a coordinate. Minus, and then the next x value, which was 9. When we simplify this, this is 8 minus a negative 4, which again turns into 8 plus 4. So 8 plus 4 is equal to 12. Divided by negative 3 minus 9 is you're already negatives and we're getting more negative. So that turns into a negative 12. Now we want to simplify it as far as possible. 12 divided by negative 12 is negative 1. So our slope is negative 1. And again, you can say it as slope is equal to negative 1 divided by 1, so that we can see the change in y over the change in x. But we can just write it as slope is equal to negative 1. On our next problem, we have 1, 6, comma, negative 5, 6. Our x and y coordinate, x and y coordinate. You can use x sub 1 and y sub 1, x sub 2 and y sub 2 if that is helpful. So in this case, this time, I'm going to use my 6 as my first y value. So I'll have 6 minus then my other 6 value, I'm going to go back to that first coordinate, is also 6. Divided by, since I used this coordinate first, I have to use this coordinate on my x on the denominator first. So I use the -5. Minus, and then I go back to my other coordinate. My x value is 1. Now to simplify, 6 minus 6 is equal to 0, divided by -5 minus 1. So -5, we're already in the negatives, and we're going more negative. That becomes -6. 0 divided by -6 is 0. This is m equals 0. This is a 0 slope. This is that special type of slope. This actually tells us that this is a horizontal line. This is a horizontal line. The graph, the line, will look like this. It is a horizontal line because it is not going up and down at all. It is only going from left to right. On our last finding the slope, we're going to do x and y, x and y. Slope equals, so the change in y, so I'm going to use the 8 minus, and then my next y is 7. All of this is divided by, since I used the 8, I'm going to use this 2 minus the next x, which is also 2. 8 minus 7 is a positive 1, divided by 2 minus 2 is 0. I cannot divide a number by 0. Our slope in this case, again, is a special slope. This is the undefined slope. Undefined. This means that we have a vertical line. This is that special type of slope that tells us we will have a vertical line. It will look like this. As a reminder, for these special types of slopes, this will also give us a special type of equation. For part C, since we have a horizontal line, our slope is 0, our equation will just be y equals b, whatever our y-intercept is. So that's just going to be y equals a number. No other variable attached to it. For part D, since our slope is undefined, this one cannot even be graphed into a calculator. This will be an x equals some number, whatever the number is. And in this case, because both of these x values have a 2 in it, this equation will actually be written as x equals 2. We can do the same thing for part C because we know it's going to be a y equals. Both of these coordinates have a 6 for the y, so this one will actually be y equals 6. We do not have to actually graph it using these coordinates because we can see that they both share the y value of 6, and on part D, they both share the x value of 2. So we can see that this will be the equation of this line.